Hi children, welcome back Physical Science Digital class. I hope you are doing well children. Children, in your previous lesson you might have learned various physical quantities. So I want to recall you those physical quantities children. Look at this table. Mass symbolized with small m. So this is a fundamental physical quantity. This quantity is a scalar quantity which does not have any direction. Units of mass is kilograms in SI system, grams in CGS system. The next one, time. Time is a physical quantity. It is a fundamental physical quantity. The units for this time is seconds. In CGS also seconds. Children, time is a scalar quantity. The third one is distance and displacement. So actually these both are same, but still there is a small difference between distance and displacement. You have learned in motion lesson, that is distance is a scalar quantity, displacement is a vector quantity. But both have the same units, that is meters in SI system, centimeters in CGS system. The next one is speed and velocity. Here also they resembles same meaning, but speed is a scalar quantity, velocity is a vector quantity. Speed, distance by time, velocity, displacement by time. Here units for these two quantities are same, that is meter per second in SI units in SI system, centimeter per second in CGS system. The next one is acceleration, symbolized with small a. Acceleration is nothing but rate of change of velocity, that is a equal to v by t. Acceleration is a vector quantity. Units for this acceleration is meter per second square in SI system, centimeter per second square in CGS system. Momentum, symbolized with p, which is a product of mass and velocity. Children, momentum is vector quantity. Unit for this momentum, kg meter per second in SI system, gram centimeter per second in CGS system. The next one is force. You have learned in laws of motion lesson children, that is Newton's second law, F equal to ma, that is product of mass and acceleration. Force is a vector quantity. It has units newtons in SI system, dynes in CGS system. Newtons in SI system, dynes in CGS system children. So children, these are the physical quantities we already have learned in our previous lessons. In this session, I am going to introduce new physical quantities. Children, in our day-to-day life, so many activities we perform, like playing, carrying the things, holding the things, lifting the weights, cleaning, sweeping. These all are activities. Generally, we often use the term work to explain this. Like, so I'm tired, I have done so much work, just now I completed, just now I finished my work, I have to do so much work today, like this. So generally we use the term work in various situations in our day-to-day life. So what is this work? Not only for the human beings, but also similarly in the case of machines. So we say generally, my watch is not working, our fan is gets spoiled, it is not working. So like this means machines also do work. So what is mean by this work? So before going to define this work in a scientific way, observe this video children. Observe here children, the boy trying to move the car. He is pushing the car, but still the car did not move despite all his efforts. He get tired. We say the boy did not do any work on the car. Okay, but the boy said, I did so much work, I did hard work, but still the car did not move. Observe this video children carefully. the bicycle, which is at rest. See children, there is no force acting on this, that's why it is at rest. Now the boy applied the force, now the bicycle moves. What do you observe difference between these two videos? What do you noticed in these videos? In the first video, the boy tried to move the car. He pushed the car, but it did not move. So in this case, science says the work is not done on the car. In the second video, the boy moved the bicycle. Means here in this case, the boy did work on the bicycle. So what is the definition of work? What is the meaning of work in scientific conception? Let us try to understand children. So in scientific conception of work, for work to be done, two conditions have to be satisfied. A force should act on an object, and the second one is the object must be displaced. Okay children? Observe here children. So a force is applied on this book which is kept on the table. Now the book is displaced. The force exerted on the object, at the same time the object is displaced. In the first video, even though the boy applied the force on the car does not displaced. In the second video, the boy applied the force and the bicycle is displaced. Means both conditions are satisfied in this case. That's why in the second video, the science says work is done on the bicycle. In the first video, the work is not done on the car. Okay children, let us try to define this work. The work done by a force acting on an object is equal to the product of the force and displacement of the object in the direction of force. Work done is equal to force into displacement. In mathematical expression, that is W equal to F into dV. Symbolize the work done as W. W equal to force into displacement. Children, work done is a scalar quantity. This is a very important equation children, that is W equal to F into D. You have to note down. As work done is a physical quantity, it has units. Like how the mass and time and velocity, force, displacement have the units, like that the work done has also units. Okay, what are the units of work done? Let us try to derive from the equation. Unit of work, we have the formula work done W equal to F into D. Unit of work equal to unit of force into unit of displacement. That is Newton into meter, Newton meter. So now we can say that the SI unit of work is Newton meter or joules, and CGS unit of work done is dyne centimeter or ergs. So what is this joule? Newton meter is named as joule in the honor of James Prescott Joule, who discovered the relationship between heat and mechanical work children. That's why we use the term joules for in the place of a Newton meter. Here 1 Newton meter equal to 1 joule and 1 dyne centimeter equal to 1 erg. Then 1 joule equal to 10 to the power of 7 ergs. Children, note down this very important conversion of units from SI to CGS and CGS to SI systems. When a force of 1 Newton acts on an object and the object moves a distance of 1 meter in the direction of the force, then the work done by the force is said to be 1 joule. Children, this is the definition of joule. Whenever the 1 newtons of force is applied on the object, when the object is moves through 1 meter distance, then it is said to be 1 joule of work is done on the object. So let's try to understand more about work done children. Let us observe this picture children. A bat hitting this ball. So the force is applied in this direction. Now the ball is moved in this direction. So here the force and the displacement both are in same direction. So when the force and displacement both are in same direction, in this case the work done by that force is positive. In the case of freely falling object. Freely falling object means the object which is falling from certain height. So observe this picture, children. So here the object is falling from certain height. That means the displacement is in downward direction and gravitational force is in also downward direction. Can you guess, children, what will be the work done in this case? Is it positive or negative? So here in this case the work done is positive because of the displacement and gravitational force both are in same direction. The work done by the gravity is positive. Let us observe other example, children. The object thrown in vertically upward direction. Here the object is displaces in vertically upward direction, but the gravitational force is at always downward direction. What will be the work done by the gravity in this case? Here work done by the gravity is negative when the displacement and gravitational force, here the force and displacement both are in opposite direction. So in such situation the work done is equal to negative. So observe this, children. Here the block is kept on the table and a push is given to this block. The block is displaces. Here the displacement is in this direction, but the frictional force, which is always opposite the motion of the object, is in opposite to the displacement. The work done by the frictional force is negative in this, children. Okay, children? So, children, whenever the displacement and force are in same direction, the work done is positive. Whenever the displacement and force are in opposite direction, then the work done by that force is negative. Okay? Observe this picture, children. Here the aeroplane flying in the air. Here the displacement is horizontal, but gravitational force is, yes, downward direction. Can you guess, children? In this situation, what will be the work done? Is it positive or negative? Here the displacement and gravitational force are right angle to each other. So in this case, work done by the gravity is 0. Why it is 0? You will going to learn this, children. The two balls are there. Here the blue ball collide with this red ball and the red ball is displaced in this direction. Now when you draw the directions for this ball and the force, so here the displacement force have certain angle theta. Those are not in same direction, those are not in opposite direction, those are not in right angle to each other. Some other angle that may be any value, 0 to any value. So in this situation, what will be the work done? Note down, children, this formula is very important. Work done equal to force into displacement into cos theta. Here the theta is the angle between displacement and force. The angle between the direction of displacement and direction of force. What is this cos theta? This is a trigonometric function. This is the cos theta is a trigonometric function. Let me explain you with the help of diagram, children. Observe here, this is a right angle triangle and corners are A, B, C. So theta is the angle between AC and BC, that is hypotenuse to base. Now the cos theta is the ratio of adjacent side to the hypotenuse. That is cos theta equal to BC by AC. Trigonometric functions are nothing but ratio of the sides. Here the cos theta equal to BC by AC. The theta values are maybe 0, 1, 2, 3 or anything. So we have some standard values, children. Note down this. The value of cos 0 is 1. Cos 30, root 3 by 2. Cos 45, 1 by root 2. Cos 60, 1 by 2. Cos 90, 0 and cos 180 is minus 1. These values are very helpful in solving the physical science problems, children. Let us do a small application problem, children. A roller pushed with a force of 100 newtons along its handle, which is at an angle of 30 degrees with the horizontal. Find the work done on moving it through 10 meters. Let's draw the diagram. This is a roller, here the force is acting along this handle, making angle of 30 with the horizontal line. Here the roller is moving in this direction, in the direction of horizontal. So now the angle between the force and displacement is 30. Here the force is given as 100 and the angle is given as 30 degrees and the displacement is given as 10 meters. So let's try to solve this problem, children. Here we have the formula, that is work done equal to FD cos theta. F 100 newtons into D 10 meters into cos theta, that is cos 30. Cos 30 is √3/2. So substitute that value in this equation and calculate the value. Now we'll get work done is equal to 500 √3 joules. Don't forget writing units, children. Units are very important in our physics. Okay, children, understood these concepts, children, that is work done have the formula actually F into D into cos theta. Okay, what happened when the theta is 0? What happened when the theta is 90? What happened when the theta is 180? Let us see. So observe this picture, children. Here the person carrying the load on his head and walking on the road horizontally. In this case, the force applied by the person is in upward direction, that is on the load. But the person is moving in this direction, means the displacement is horizontally. Now the angle between force and displacement is 90. That's why we have the formula work done W equal to F into D into cos theta, that is W equal to F into D into cos 90. You will get 0 only. So due to this reason, whenever the force and displacement are right angle to each other or perpendicular to each other, the work done by that force is always 0. In such situations like force and displacement are right angle to each other. Okay, observe this picture, children. In the second case, here the person carrying the load and climbing up the stairs. Here the displacement is upward direction. Force is upward direction and displacement is also upward direction. What will be the angle between these two? So when the both are in same direction, the angle is 0. That's why work done equal to F into D into cos 0. What is cos 0 value? Cos 0 is 1. Yes. So when you substitute 1 in the place of cos 0, you will get F into D only. Means in this case, work done by the force is positive. Let's move to the another case, that is observe here, children. Here the person comes down the stairs. That is, the force is acting upward direction and the displacement is downward direction. What is the angle between force and displacement? Here the angle between force and displacement is 180 because of both are in exactly opposite direction. That's why angle is 180. What is cos 180? Cos 180 is -1. When you substitute -1 in the equation, you will get negative work done. So in this case, the work done by the person is negative. So whenever the force and displacement are in same direction, work done by the force is positive. When the displacement and force are in opposite direction, then the work done is negative. When the force and displacement are perpendicular to each other, then the work done by the force is 0. What happened when the work is done on the object? Already have learned about whenever the force is exerted on the object is moves. Object change its position from rest to motion and motion to rest. So what happened when the work is done on the object? When you see the objects, you only observe the motion of the object, children. Okay. So there is another thing which is happening which is not visible to our eye, that is transfer of energy. When the work is done on the object, energy transfers takes place. So how it is possible? Let me explain with an example, children. Observe, children, here a teacup placed here and there is a ball which is in contact with this. Here both are at rest. No force is acting on these two objects, both are at rest. Gravitational force, frictional force always exist on these objects, but there is no net force, there is no external force on this object. But when you exert some force on this ball, the ball moves. Okay. So when you exert some force on this object, the ball is displaced. The ball displaced and the ball is pushes the teacup also. So what happening in this situation? With your eye you can observe only those are displaced simply. But the transfer of energy takes place in this situation, in this condition. Whenever the work is done on the object, energy transfer takes place. Observe here, children. What is this energy? Before going to explain transfer of energy, what is this energy? We often use this energy in our day-to-day life, like I'm tired, I need some energy, I lost my energy, like this. And also you heard some energy sources like solar energy, light energy, electrical energy, like this. So often we use this word in our daily life. Then what is this energy? To do work, we require energy. To do any work, we need some amount of energy. What is this energy? Let's try to define this energy situation. In this case, children, the capacity of an object to do work is energy. Energy has units same as work. That is joules in SI system and X in CGS system. So units for the energy and work done both are same. Means work done is nothing but energy, energy is nothing but work done. Okay, children? So observe here. When the work done by the force on the object is positive, then the object gains energy. When the work done by the force on the object is negative, then the object loses energy. When the work is done on the object gains the energy. When the work is done by the object, then the object loses the energy. So it is very important, children. Note down these 2 points. When the work done on the object gains the energy. When the work is done by the object, then the object loses the energy. So observe here, children. Here just now I shown you. Here the ball and the block kept here. So when a push is given to this ball, the ball pushes the block. So where this energy come from? So how the ball able to push the block? How the ball is able to push the teacup? Whenever we given a push to the ball, there is a transfer of energy from that force to that ball. And when the ball pushes the block, then the energy transfer from that ball to the block. What do you observe here? When the object gains energy, what happening? Here in this example, we observe that whenever the force is exerted on the object start moves. That means velocity is increases. Means once the object gains energy, it moves. Means the energy acquired by the body due to its motion is known as kinetic energy. We have to name that energy because there are so many various types of energies are present in this universe. So, but here whenever the object gains energy due to motion, due to its motion, that energy is known as kinetic energy. The kinetic word which is derived from Greek word that is kenon, which means to move. So what is this kinetic energy? And let me explain with an example, children. Children, you can carry the bullets in your pocket, no problem. But when you carry the bullet which is fired from a gun, can you carry it? No, we cannot hold those bullets whenever it is fired from a gun. It makes small hole on your hand. So means what? Whenever the bullets are at rest, it is not harmful. Those are not have that much energy. But once it is fired from a gun, it has very high speed, means it has very high amount of kinetic energy. Due to this reason only the bullet can penetrate through any object. So means object gains here energy due to its motion, due to its velocity. Observe here, children. Here in this picture, a meteorite going to collide with the earth. It has very high speed. Whenever it is hits the earth, there is a huge crater formed on the earth. You can observe in the second picture, children. It is a crater which is formed on the surface of the earth. Means even though earth has huge mass, the meteorite has less mass, but still it is moving with, it is coming with a high speed. That's why whenever it is collide to the earth surface, it forms the crater. It forms the crater on the earth surface. Means object has high kinetic energy whenever the velocity is very high. Let us try to derive the expression for this, children. Object of mass m placed here, which is having the initial velocity is 0. Whenever the force is exerted on this object, it moves, and let the final velocity will be v, and the distance is say s with an acceleration a. You have learnt in motion lesson, that is v square minus u square equal to 2as. So here the initial velocity u is 0 and acceleration a equal to f by m. This is taken from the Newton's second law, that is F is equal to ma, a equal to F by m. Substitute u value and a value in the third equation of motion, then you will get here v square equal to 2 into F into s by m. When you bring the m from RHS to LHS, it will be in multiplication to the v square, that is mv square is equal to 2 into F into s, that is F into s equal to mv square by 2. What is this F into s? That is nothing but work done. Whenever the work done is on the object, it is stored as energy. Here the object velocity is increased, that's why this work done is stored as a kinetic energy. So here the work done is equal to kinetic energy, which is equal to half mv square. The kinetic energy of a body of mass m moving with the velocity is half mv square. So find the kinetic energy of a ball of mass 400 grams moving at a speed of 50 centimeter per second. Mass of the ball is given as 400 grams, which have to be converted into the kgs, that is 0.4 kg, and speed of the ball is v, that is 50 centimeter per second is, and it have to be converted into meter per second, that is 0.5 meter per second. Kinetic energy Ke equal to half mv square. Substitute these values in this, children, that is you will get 1 into 0.4 into 0.5 into 0.5 by 2. Here the v square, that's why I multiply twice. So kinetic energy is equal to, when you multiply these values, 0.05 joules. So I think you understood the formula, children. So let us try to recall all the concepts whatever we learn in this session. So here the work done is equal to force into displacement, that is W equal to F into S. Work done is a scalar quantity. The SI unit of work is Newton meter or joules. The CGS unit of work is dyne centimeter or ergs. When the force and displacement are in same direction, the work done is positive. When the force and displacement are in opposite direction, the work done is negative. When the force and displacement are right angle to each other, then work done is 0. The capacity of an object to do work is known as energy. Energy units and work units are same. The energy acquired by the body due to its motion known as kinetic energy. The formula for the kinetic energy, children, that is half mv square. So children, these are the important points. Note down these points, children. Here the m is mass and v is the velocity. So to improve your learning, try to answer these questions, children. In the adjacent figure, give the sign convention for work done by the various forces acting on the block. Give example for object which possess kinetic energy. Define work and write its units. Find the expression for the kinetic energy of a body of mass m at a speed v. For more improvement of your learning, please visit the SCERT website, download the worksheets and try to practice the answers, and as well as try to solve the problems which are given in the worksheets, children. So children, will meet in the next session with interesting concepts like potential energy and conservation of energy like this. Okay children, thank you.